All right, these are your notes for shape of data distributions. Okay, so the shape of a data set shows the arrangement of data values. Data is considered symmetrical when the left side of the distribution looks exactly like the right side. So if you think about symmetrical, a lot of times you hear this word the most in art when you're talking about lines of symmetry. But if something is symmetrical, when you cut it in half, straight down the middle, the left side is identical to the right side. So like this heart has symmetry because when I cut it down the middle, the left side and the right side are symmetrical. They're the exact same. Same thing with the star and the circle. So if a data is not symmetrical, it's considered skewed, or you could say non-symmetrical. So there are 4 different graphs here, and we're going to look at labeling these graphs. So this graph, if I were to cut it straight down the middle, right here, it is the same, exact same on both sides. So I would call this graph symmetrical. This one is obviously not symmetrical, but it's not skewed like these are, where a lot of the data is on one end. It's just not symmetrical. So we're going to say non-symmetrical for this one. For this one, we consider the data to be skewed left. So skewed means off. So it's off on the left. There's more of them on the right. So this one is considered, wow, that's where I can write, skewed left. And this one is the opposite. There's less data on the right, so it's considered skewed right. Okay. There are also different ways that you can define the data. So a cluster is data that is grouped closely together. A gap is a number that does not have a data value. And if you remember when we did dot plots, we talked about gaps. And then a peak is the most frequently occurring value. We also know that is the mode. So we're going to take this data and we are going to determine if it's one of these, symmetrical, non-symmetrical, skewed left or skewed right, and then we're going to answer these questions. So I'm going to write symmetry down here, and we're going to define the type of symmetry it has. Okay, so if I were to cut this data in half, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So at the 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here is the middle of this data. Is it symmetrical? The exact same on the right, on the left and the right? No, it's not. It's not necessarily skewed left or skewed right. All the data is not on one side. So we can't say skewed. We're just going to say that this one is non-symmetrical. And now that we've determined that, let's go figure out if there's any gaps, clusters, peaks, or outliers. So gaps is a point where the number does not have a data value. So there's a gap at 5, from 5 to 6. So gaps would be from 5 to 6. And there's also a gap at 8. Okay, there's no data points here. They're missing. Clusters are where they're grouped close together. So I would say this is a cluster from 1 to 4. There's also a cluster from 9 to 12. So in order, grouped together, they're sequential. A peak is going to be the mode or the highest point. So I would say there's a peak at 10, because that's the highest point. It's the most frequently occurring value. So there's a peak at 10. And then are there any outliers? Are there any numbers that are way off here all by themselves on the dot plot? And here there are none. So no dots way out there are off by themselves in no man's land. So no outliers. The peak is the mode, the highest point. Clusters are where they're grouped together. So this is clustered from 1 to 4 and from 9 to 12. And there are gaps from 5 to 6 and at 8. And then symmetry, it is not symmetrical. It's not the same on both sides. It's non-symmetrical. We didn't pick skewed left